Hi everybody, welcome to my series on MPLS. In this particular series, we'll be taking a look at a basic MPLS VPN. We'll take a look at MPLS VPN with a DMVPN setup. We'll take a look at MPLS VPN with DMVPN using a front door VRF as well as an internal VRF. It's a four-part series. This is the first one where we'll set up a topology. Well, it looks like that, where I have my service provider cloud over here. I'm going to put the service provider in AS, let's say 1000. I'm going to run some type of IGP over here. I'm going to go ahead and choose EIGRP as my IGP, which is a little faster to set up. Once I'm done with the core setup of the service provider using MPLS VPN, I'm going to be connecting up my 4 sites belonging to the same customer, which is London, Dubai, Los Angeles, and New Delhi, to each other so that they can communicate to each other by using an MPLS VPN. That's the objective of this particular video. Once we're done with this particular video, which is the MPLS VPN video, in this particular series, I'm also going to take a look at how MPLS VPN works with DMVPN, the basic setup to encrypt your MPLS traffic. Once we're done with that, we'll take a look at how to segregate traffic by using an internal VRF inside so that when the traffic comes in from the outside into my site, I can segregate it into 2 different VRFs inside my particular location. At that point in lab number 3 or series 3 or video 3 of this particular series, we're not going to use a front door VRF. We're just going to use an internal VRF for the purpose of segregating the traffic. Once we're done with that, the 4th video, the last in the series, we'll take a look at how to do a internal VRF with a front door VRF, which we'll use to make a connection between the different sites. This is generally done when you have multiple service providers or multiple connections from the service provider towards your customer sites. So let's get started and set up our initial setup, which is the MPLS VPN. For this particular company, what I'm going to be doing is setting this topology up where I have the core with service provider AS1000. The way I've set this topology up logically is like this. I've set up router, this is not router 4, I'm going to change this. This is going to be my route reflector. My objective over here is to segregate my control plane traffic from my data plane traffic. So in essence, if I get a packet, let's say these R1, R2, R3, R4 are my provider edge routers. They're connecting to different sites. So let's say I have a customer over here. Let's take an example of this being London. When London, the customer edge router over here sends the traffic, he's going to send the route to my PE router, which is R1. R1 will have an MP-BGP relationship with the RR. He's going to forward that packet to the RR. He does not have any relationship with the other provider edge routers. Router 1, router 2, router 3, router 4 are all provider edge routers, which will be connected to all the different sites. The RR is going to be responsible for sending those routes, the MP-IBGP routes, to all the other provider edge routers without changing the next stop. The next stop will remain as R1. So when, let's say I get a route, let's say 10.1.1.0/24 into R1, R1 will forward the route to the route reflector, which takes the route and forwards it to R2 as is. So on R2, my route that I learned, which will be 10.1.1.0/24, it would be reachable through a next stop, still pointing to R1's IP address. So if that's the case, the advantage of doing that is I'm also going to connect R1, R2, R3, R4 to each other over a flat network, which is basically on the same 192.1.100 network, and R2 to reach R1 in terms of data traffic. Because the next stop is R1, it's going to find its way through here. So the data will flow through this high-speed direct connection between the 4 PE routers, whereas their control plane will be sent through the route reflector. By doing that, I minimize the number of relationships that I have between the provider edge routers by sending it all to the route reflector, and I segregate my data plane traffic from it. You might think about this being a single point of failure. You're right. But the way I get around that is probably not, I'm not doing it in this particular lab, but Generally, what I would do is over here, I would set up two route reflectors in a cluster. So this would be RR1 and this would be RR2. And then I would form a relationship between all the routers also to RR2. So just in case RR1 goes out, I still have communication in terms of control plane propagation of routes through the second RR. I'm not worried about that. That's not my focus over here, but that's a way to get around that problem of a single point of failure with the route reflector. This is a logical diagram. Physically, the way it is, it's like this. So this is my RR. All these networks over here will be different networks. Although R1, R2, R3, R4 will be on the same network over here, they also have these connections here. Then R1, R2, R3, R4 are the provider edge routers, which are connecting towards your four customers. Customer A has 4 sites, Dubai, London, Los Angeles, and New Delhi. These are the 4 sites that I'm going to be using to connect up my customer to each other. So the first thing that I need to do over here is set up my service provider network. My objective in the service provider network, let's take a look at what are the different things that I'll be doing over there. In the service provider network over here, my objective is basically, one second. All right, so my first objective over here is to get my MPLS VPN up and running. In that, what are the different steps that I'm going to take? Number one, IP addressing. Set the IP addressing between the different devices. Number two, I need to set up routing for the IGP. I'm going to be using EIGRP as my IGP. It's a little quicker to reconverge. Once that's done, I'm going to set up MPLS unicast routing, basically running MPLS IP and using LDP to exchange the labels for all the reachability, for the PE router reachability. And once that's done, then I'm going to do the MPLS VPN setup to connect the different customers to each other. For this type of setup, I'm going to use the PECE routing protocol. Let's go ahead and just keep EIGRP as a routing protocol, so that, or actually we can use, yeah, let's just use EIGRP as my routing protocol for my PECE as well in this particular example. All right, we'll get to that later on. Let's start with IP addressing. My IP addressing, if you take a look at it, I'll go back to this diagram. I'm just using GNS over here for my diagram purposes. My switch network is 100.0/24. The networks from R1 to the RR are based on this. R1 to the RR, that particular network is 192.1.1.0. R2 to RR, that particular interface is 192.1.2.0. I'm going to use RR as 9. R3 connected to RR, that particular network I'm going to say is 3.0. And R4 connecting to RR. All this R1, R2, R3, R4 link to the RR is for the purpose of propagation of routes. This is where my neighbor relationships will be formed for IBGP between R1, R2, R3, and R4 towards RR. The 192.1.100 network, the one I'm going to have on my routers as well, that particular network I'm going to be using for the purpose of the data plane traffic. So the next stop reachability from R1 to R2 will be through the switch, because they're going to be on the same network. So that's what my objective over here is. So let me go ahead and get into my devices over here. This is R1. All the routers right now are blank. For right now, I'm just focused on the core routers. And this is going to be my RR over here. E0 on this router is going to be the one that is connecting to, I'll do my en config t, line con 0, log sync, no IP domain dash lookup, and then my host name, leave it at R, copy it, let's go down over here, and I'll paste it. This is R1, this is R2, this is R3, R4, RR. Alright, my first link E00 is the one that is connecting me to my RR. So what I'll do over here is set up this particular link 1.1. Alright, I'll also create a loopback 0. This is the one that I'm going to use for my neighbor relationships. And my E02 is the one that is connected to that common network 100.1. Alright, so that takes care of my router 1. Let's do router 2. E00, that is the connection towards my RR 2.2. My loopback, that is going to be used for my IBGP neighbor relationship. E0/2, that is the common network, and that I should be able to ping R1 on for right now because that's the only one that's up. Alright, R1 and R2 on that common network can ping each other right now. Let's go to router 3, do the same type of setup. 3.3. Done. E0/2, that common network that I have. .1 and 100.2 should be pingable. Let's do router 4. .4 E02 100.4 common network. 100.1 should be pingable. 2 should be pingable. 3 should be pingable. Now my route reflector in the middle, E00. This is connected to router 1. So I'll say 1.9. This is 2.9. 3.2, which is 3.9. Alright, so let's do a ping to verify connectivity. 1.1, 2.2, 3.3, 4.4. Brilliant. So my devices are communicating to each other. I have my IP addresses set up. Now let's go ahead and set up my EIGRP. We'll use Autonomous System 100. Actually, I'm running 15.x, so I don't need to do no auto summary. I'm going to put it on the 100. Actually, 100 network I'm not connected over here because that's just for the data plane traffic. So I need 1.0, 2.0, 3.0, and 4.0. Good. And then on the other devices, .1.0, 100.0. All right. By the way, over here on the RR, I'm also going to create a loopback 9999 and advertise it in EIGRP. And I'm going to set my neighbor relationship based on that. Cool. So if I do show IP route, EIGRP over here, I should have 9. Let's go to router 2 and set the same thing up. So should be good to go now. Dual reachability for that network. I have the one network over there as well. 2 is myself. 3.0. Done. 1, 2, 3 is myself. And now the last one. So all my reachability is done. The next thing I want to do is I want to set up MPLS unicast routing over here. So my LDP should be able to communicate on all these links. How do I set that up? Let's start with the router 1 and then move up. Interface E0/0, MPLS IP, E02 MPLS IP, MPLS LDP router ID, and I'm going to say loopback 0. Force it. MPLS LDP router ID loopback 0. Go into my 2 interfaces. Should form a neighbor relationship for LDP over here with 2 between 2 and 1. Same thing over here, MPLS loopback 0. That's router 3. Now router 4. By the way, E00 is that connection between the router and the route reflector. E02 is that data plane network that I have that connects R1, R2, R3, and R4 to each other. So if I go back to my diagram over here and I want to label it the way it goes, all these are E0/2s. So you know how they're communicating to each other. And this guy over here is your E0/0. And then goes E0/3, 2, 1, 0, 0. All done. That's what I've done right now and ran MPLS on it, except for I don't think I've ran it on my, I haven't done it on my route reflector yet, so I need to do that over there. MPLS LDP router ID is loopback 0, and I go under my interfaces, all of them, and enable MPLS over there. So I'm using unicast routing, MPLS unicast routing on the core. So with that done, the next thing that I'll do is I'll configure my RR to establish a neighbor relationship with my 4 PE routers, which are router 1, router 2, router 3, router 4. So how do I do it? I'm going to do it in Notepad and then paste it. So router BGP 1000, neighbor 111. Actually, what I'm going to do is I'm going to do an IBGP peer group. Remote AS is also 1000 for all of them. IBGP. I don't need next hop self. I need route reflector. Client. Neighbor. That should be it. Do I need anything else? No, I don't need next hop self towards them. That should be good enough. Address family. VPN v4. Neighbor 1.1.1.1. Well, actually, now I need to set them up. Neighbor 1.1.1.1, peer group, IBGP. Activate. Alright, this is done. Neighbor IBGP. Send community. Let's say extended because that's all I need really. And neighbor IBGP route reflector client. I actually don't even need this over here. Oh, I do need this. Oh, I don't need this. I know I was, because I don't have any IPv4 routes. I have VPN v4 routes. I update source is loopback 0 for all of them. That's what I needed. So let's check that and do that on my route reflector. Copy. On my route reflector, paste it. Looks good. Now on R1, R2, R3, R4, this remains, I don't need this. Everything will point to 9.9.9.9. I don't need any peer group because I'm only forming it with this guy. Update source will be the second command. The first command should be the remote AS. I don't know why I erased that, but that's okay. We can type it in again, and we can do next hop self. All right. That's all I really need over here. And then my neighbor. Activate it. I don't need these three. Copy it. I'll go down over here to router 1. Paste it. Go to 2. Paste it. Go to 3. Paste it. Go to 4. Paste it. Let's see if the neighbors are coming up. First one up. 2 up, 3 up, 4 should be coming up. So my MP-BGP neighbor relationship between the 4 PE routers is set up. Okay, so now I have my data plane traffic, my control plane traffic all segregated. My route reflectors are going to be reflecting the route. In my case, I only have one, but the next hop for whatever routes that I learn will be kept as the same. So R1 to R2 will be communicating directly to each other, although the route propagation will happen through the RR. Now my objective over here, as I told you earlier on, was to connect my 4 sites to each other. My 4 sites, one R5 being in Dubai, London, Los Angeles, and New Delhi to each other over my service provider network. So as we decided, we're going to use EIGRP as my PEC routing protocol. We're going to do that. We've done these 3 steps right now. So the next thing is to set up the MPLS VPN. I'm going to be creating the VRFs and then propagating the VRF information from one provider edge to the other provider edge. So let's start by doing it on the first device, that's router 1. What I'm going to be doing on router 1 is I'm going to be defining a VRF. So these are the steps to set up an MPLS VPN configuration. We'll start by setting up a VRF. In the VRF setup, I am going to be defining the RD value, and I'm going to be defining my RT export, import and export basically. I'm going to keep it the same. For this particular customer, I'm going to keep it as 1000, which is my ASN :1. This is my first customer. Once I create my VRF, I'll assign it to the interface. It's called the VRF definition. The next thing to do is assign the VRF to the customer interface. We'll do that. And the third thing, run EIGRP between the PE and CE. We'll do that to run it within the autonomous system. Last but not the least, redistribution to allow forwarding of the routes from PE to PE via RR. Alright, we'll do that. These are the steps that we need to take to set up an MPLS VPN between the different devices. So let's start with the VRF definition. I'm going to do it over here because then I can copy paste it. VRF definition RD 1001, that's what we agreed upon. Once I'm done with that, address family IPv4. In here I'm going to say route target both, to keep it simple, 1001. That's step 1. Step 2 is my interface. My interface over here is E01. That's the customer facing interface. IP address, let's say, is 192.1. Let's check. It is going from 1 to 5, so I'm going to keep it as 15. This has 26, this has 37, and this one as 48, this particular link. Alright, so with that in mind, let's go ahead and set this as 15.1, 255.255.255.0, but always remember, don't forget to put the forwarding first for the customer. And I need to define that. Cast A, I'm going to say VRF forwarding, cast A. Bring the interface up. Let's do these 2 steps to get the interface up and running. That's step 1 and step 2, A and B. So copy this. I'll go to router 1. Done. Zero 1 changed. Oh, wrong one. Default, I needed to do it on R1. E01, which is 2.2. Set that back. IP address was 2.9. Wrong device. MPLS IP. There you go. I need to do that pasting on R1. VRF definition, interface up, show IP route VRF cast A, 15 is up. Now for the second one, this remains the same. All I need to do is change the IP for router 2, which is 26.2. The rest remains the same. That's why I like doing it in Notepad, so I can paste it easily. Router 2. Just check to make sure my interface comes up. Good. Moving right along, I'll set this as 37.3, the third interface between 3 and 7. Copy it. Go to router 3. Paste it. That looks good. Router 4, I need to change this to 48.4. Copy it and paste it to router 4. Should be good to go. There you go. My RR should be back up. Neighbor up. Show IP. Summary, I have all for neighbor web on RR. Going back to that. So I've done the first two steps, assign it. The next thing to do is run the EIGRP. But before I do that, I'm going to bring up the other 4 devices over here, my 4 PE routers, which starts with 5, 6, 7, and 8. Let's set at least the IP addresses over here so that we can see if it communicates to the device or not. Again, did I keep that EN? Nah. Alright, that's okay. We can do that again. EN config T line con 0 log sync IP domain dash lookup hostname R, and I will just copy it and then paste the rest. Last portion of it, start with 5, go to 6, 7, 8. All right. Now E00, that's R5, so this is going to be 15.5. And I should be able to ping 15.1, which is the PE router R1. Similarly over here, 26.2 or 6 over here, 26.2 is what I want to ping. Okay, I'll get it right. There you go. This is going to be 37.7. 37.3 is what I want to ping. Good. And the last one, 48.8. Cool. So everything is communicating between the CEP. The last step, run the routing protocol. So over here on the CE routers, let's do our CE routers, get that out of the way, and then we can worry about getting my PE routers done. Here I'm going to be creating a loopback each. I'm going to create 5.5.5.5. Actually, let's create 2. Loopback 0 and 1. 10.55.55.55. All right, run EIGRP. I'm going to run it in AS1 or 1234. Let's do that over here. Network is 15.0 and network 10. All right, on R6, loopback 0. I'll say 10.6.6.6, loopback 1. Done. EIGRP 1234, network 26.0 and 10. R7, interface loopback 0, 10.7.7.7, 10.77.77.77, 37.0, and network 10. And the last one, 8.8.8.8, 88, 48.0, and 10. So all my CE routers are ready, routing. So the next thing to do over here is to set my PE routers for routing. What I'm going to do over here on my first PE router, which is router 1, I'm going to run all my PEC protocols in EIGRP 1, but this is for the address family. So I'll say address family. IPv4, VRF, cast A, autonomous system is 1234, network 15.0. That should get my EIGRP neighbor relationship up. Show IP route, VRF, cast A, my 10, 5, and 55 are here. I'm going to redistribute these routes into BGP, and BGP routes I want to redistribute into BGP, into EIGRP. So redistribute, followed by BGP 1000, because this is going to be going into EIGRP. The routes that I get from my other P routers will be in my VRF as BGP routes. I'm going to send them into my customer router. At the same time, I'm also going to redistribute these routes into BGP under the address family. PV4 VRF, cast A, redistribute EIGRP 100 or 1234. Done. When you do that, on R1 in your BGP table, show BGP VPN v4 unicast. I don't know what's happening over here. The tab's not working, and we'll do all. You'll see 10, 5, and 55 into my MP-BGP table. Now on R2, I'm going to do something very similar to this. Router EIGRP1, address family, IPv4 VRF, cast A, network 26.0. Actually, I need to set up the autonomous system over here. Alright, network 26.0 should establish a neighbor relationship with him. Redistribute BGP 1000, biometrics, router BGP 1000, and over here, address family, IPv4 VRF, cast A, redistribute EIGRP1234. Now let's check it. Show BGP VPN v4 unicast all. There you go. 10.5, 10.6 are there. 55, 56 are there. Let's finish this off now. Router, this one is done. So router EIGRP1 address dash family IPv4 VRF cast A autonomous system is 1234. Network should be 37.0. Should establish the name relationship. Redistribute BGP 1000 metric 5 ones router BGP 1000 address family IPv4 VRF cast A redistribute EIGRP 1234. Do show BGP VPN v4 unicast all. Should see all the routes. And the last one, router 4, router EIGRP1 address family IPv4 VRF cast A. Oops. Exit. You need to specify autonomous system as 1234. Now I can do the network statement. 48.0. Redistribute BGP 1000. Metric is the 5 ones. 1000. Boom. Do show BGP VPN v4 unicast all the routes are there. Now if I go to my CE routers, it should be learning all the routes. Show IP route EIGRP 10.6, 10.7, 10.6, 7. 5 is myself. 8 has not propagated yet. Give it some time. I just got the BGP up and running, so eventually it should also come. Let's take a look at 6 in the meantime. Show IP route EIGRP. 5 is there, 6 is myself, 7 is there. Show IP route. 5 and 6, 7 is myself. 8 has not come yet, so let's check why. I'm getting 7, 8 in all of those. Okay, I didn't call them 10, 8, I call them 8 and 88, so I'm going to change that to match the other ones. IP address is 10.8.8.8, 10.88.88.88. So now if I go back to 5, 8 and 88 are there. So all my routes are there. I should be able to ping 10. Let's say 6.6.6 source of loopback 0, or for that matter I should be able to ping 7, or I should be able to ping 8. Now if I do a trace, you will see the trace give you a better result because it'll show you the hops that it's going through to get there. It goes to router 1, which is 15.1, and then jumps directly to router 2, which is 26.2. It doesn't need to go through the RR because RR, if you look at R1, when it receives the route, or R2, when it receives the route in its routing table, it receives it directly from next stop is 1, next stop is 3, next stop is 4. So it doesn't go through the RR. RR does not change the next stop. Hence, my traffic, if you look, that's what I was trying to show you over here. My traffic that is going through is going directly from 1 to 2 to 6. It's not going through the RR. So I don't have a bottleneck on RR. I've segregated the traffic between my data plane and control plane. the purpose over here was not to go through MPLS VPN. My assumption over here, the people that are going to go through this series are people that are already aware of MPLS VPNs. Their main objective in this particular series is to be able to see the integration between DMVPN and MPLS VPN, and that's what's coming up. The next set of labs that I'm wanting to do over here are going to be for that purpose. So my objective over here, actually, where did I write it? I think I have it here in my text. My main objective over here was these three things. But in order to do that, I needed to first get my service provider up and running, my MPLS VPN up and running, which I did in this particular lab. So please continue on. Wait for the update. The next lab that I'm going to be doing over here is the one with MPLS and DMVPN together, a basic one without any front door or internal VRFs. I'm just going to integrate DMVPN and MPLS together so that you can see that you have the ability to encrypt your MPLS VPN using a DMVPN infrastructure. Plus, I'll also set it up in such a way that we do DMVPN phase 3, where the NHRP redirect and shortcuts are used. All right? Till then, you have a good one and wait for the update for the next one. Thanks, guys. Thanks for watching.